Hello, algebra students. This video is a review video. It is for my honors first period, second period, seventh period, and eighth period classes. Yeah, that's all of you. There is going to come a point where I can tell the second, seventh, and eighth period classes to stop watching. You don't need to know beyond here, and there it is right there. So you're going to do the first 7 problems. Now, ideally, I'm posting this early. You should watch part of the video, try the problems, and then watch my solutions, and then come back to it later. So there's 2 problems right there. Go ahead and pause the video, see what you can do. And I don't know if you notice, I got something funky going on with my my pens up here. The colors aren't showing, but that's okay. So go ahead and pause the video. Here come my solutions. If you haven't tried 1 and 2 yet, please do. All right, I'm multiplying these monomials together. And remember, when I multiply like bases, I add the exponents. The first thing I do is I'm going to multiply the 5 and the 3 and get 15, right? And then I'm going to multiply x cubed times x to the 5th. Well, that would be an x to the 8th, because like bases, x cubed times x to the 5th. You could say, well, this is x times x times x, and this is x times x times x times x times x, which is x to the 8th. Or you could say, hey, like bases multiplication, I add the exponents. All right, the y's are y to the 10th, right? Y squared times y to the 8th. And the z's are, did I fool you? Did you think it was z to the 9th? It's not. Remember, there's a little 1 there, so it's actually z to the 10th as well. And there you go. Okay. Problem number 2, you know what? You can do it straight up, or you can rewrite it as a fraction. Sometimes writing things as fractions makes them easier. I think many of you are starting to believe me about that now. I know at the beginning of the year you were terrified of fractions, and really that's a shame because they make math so much simpler. But if you're getting that fractions make things easier, then that's a good thing, that we're making some headway. So the first thing I'm going to do here is I'm going to simplify 30/20ths into 3 over 2. Okay, x to the 7th divided by x to the 10th. Well, that's going to be an x cubed in the denominator. Now, by the way, if I did it this way, x to the 7th divided by x to the 10th, couldn't I get x to the negative 3rd? And a negative exponent means to use the reciprocal, and so wouldn't that be 1 over x cubed? And my x cubed is in the denominator. And look, my x cubed is in the denominator. Just another way to think about it. All right, y to the 8th divided by y to the 8th, they're going to cancel out. And z to the 12th divided by z to the 8th, that would be a z to the 4th in the numerator. And there you go. All right, here come a couple more problems. Okay, let's see here. Let's go with a different color for this one. All right, 2 to the 3rd raised to the 4th power. Now, when I do this, I'm going to want it as a base and an exponent. I'm not going to actually evaluate it. All right, well, if you're thinking 2 to the 7th, you're incorrect. Remember, this 4 means that there's 4 of those. So there's a 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Now, am I going to multiply these 2's together? No, 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 because this is 2 times 2 times 2. And so is that. So is that. And so is the last one. How many 2's are being multiplied? Well, it looks like there's 12. Okay. Now, this is an awful lot of work. If you have to do that much work to get it right, fine, but I don't think you do. I don't think you do. Remember that when their bases are the same, we just add the exponents. So if you look here, our bases are all 2. So we're just going to add our exponents. And you could say 3 plus 3 plus 3 plus 3. Oops, sorry. 3 plus 3 plus 3 plus 3, which is 12. Or you could have just said 3 times 4 is 12, right? Because when we're raising a power to a power, that's when I can multiply the exponents together. All right, now B. Some of you are going to go, all right, I'm going to get an x to the 18th. I know, I just learned that from Mr. Lawrence. I'm going to multiply 6 times 3. And then I'm going to multiply y squared times 3, and I'm going to get y to the 6th and a z to the 30th. And then you're going to say, it's 15, and you're wrong. It's not 15. What's the exponent on the 5? It's a 1. So if I multiply the exponents, I'm going to get 5 cubed. Now, this is not a good answer because I should figure out what 5 cubed is, which is 125. And there we go. There's our answer. Okay. All right. Problem number 4. Go ahead, pause it, see what happens. All right. Here comes my solution. First thing I'm going to do is I'm going to take care of this -3. So I'm going to rewrite it as 36 x to the 10th, y to the -5th, z to the -6th. And I'm going to put that over 24 x to the -8th, y to the 5th, z to the -2nd. And now it's raised to the second power, or the third power, excuse me. Negative exponent means these are reciprocal. I took the reciprocal of everything inside. Now I'm going to highlight, wow, this is strange. I'm going to highlight the terms that are going to move. Well, this guy's going to move. This guy's going to move. This one's going to move. And this one's going to move. So I'm going to rewrite it like so. So I'm going to have, hey, by the way, I just realized 36 and 24 can simplify. I can divide them both by 12. So I'm going to get a 3 in my numerator and a 2 in my denominator. Remember, you can simplify at any time. I'm going to get x to the 10th times an x to the 8th. I'm going to have a y to the 5th times another y to the 5th, right? Because this one's coming down, right? And this one up. Okay, and these guys are actually switching places, aren't they? And so I'm going to have a z squared in the numerator and a z to the 6th in the denominator. And that'll be to the third power. Now I'm going to simplify it as much as possible. And so I'm going to get a 3x to the 18th over a 2y to the 10th with a z to the 4th in the denominator as well. Now I need to cube everything and I'll be done. 3 cubed is 27. X to the 18th cubed will be x to the 54th, I believe. 2 cubed is 8. Y to the 10th cubed would be y to the 30th. And z to the 12th. And there you go. Okay, now if you're worried about practice problems, that review sheet I made up has tons and tons of them. Please do your best on it. Do as many as you need to do so that you can be successful. All right, moving right along. Let's see here. All right, there's problems 5, 6, and 7. Again, go ahead and pause the video and see what you can do with them. Uh-oh, I see a mistake here. Let me change this. It's not supposed to be a 2. I think that's supposed to be a 7. Yeah, that's supposed to be a 7 there. There we go. Sorry about that. Okay, so check the other ones really quick. Yeah, they're good. Okay, so remember that the denominator of the exponent tells me what root to take. I believe I heard Chandler Brown say that Monday in class. And the top one is the power. I'll always take the root first, but if possible, I'll simplify first. Okay, so let's see here. The 7th root of 128. If you're going to do that on a calculator, you need a 7. You're going to need the key that looks like this, and then a 128. That means the 7th root of 128. I believe that's 2. So now I have 2 to the third power, which is 8, and there you go. This equals 8. If you're not sure how to do that on a calculator to check your answer, let me know. Here I need to take the cube root of 1,331. Well, I believe that'll be 11. I need to square it, which will be 121. And it's too easy. All right, I've got a negative here, and then a 3/4 power. I don't think I'm going to take care of this negative first. I think I'm going to take the 4th root first. I think it'll be easier to do. So I'm going to take the 4th root and get, hold on one second. Let me just make sure it's going to turn out the way I think it is. I made a mistake at the algebra party and we caught it, but I don't want to repeat my mistake. So 16, 81st, I'm just using my calculator and checking something. Negative 0.75 power. Math rec. Okay, yeah, I think it's going to work. I'm going to take the 4th root before I do that negative exponent out there. So when I do my 4th root, I'm going to get 2 over 3, and I'll have the negative 3rd, right? Okay, now I'm going to worry about that, and I'm going to get a 3 over 2, and that'll be to the positive third, and then I'll cube and get 27 over 8. Okay, so when you have a situation like this, don't take the reciprocal of that fraction because you have to take the fourth root, and these are do have perfect fourth roots. They do not have perfect cubed roots, and so that'll make it more tough. So on this particular case, and I'm going to investigate that because that's bothering me why that happened that way. I'm going to say your first step will be to take the fourth root. Okay, and I need to figure out why you couldn't do it another way first. So, second period, seventh period, and eighth period can stop at this point. First period, we're still going. All right, I need the volume of this rectangular prism, and what means I'm going to multiply the length, width, and height to get the volume. So I'm going to have 3x y to the fifth z squared inches, and that'll be multiplied by 2x squared y cubed z inches. But what are these little marks here? That means these two sides are the same. So I'm going to have to multiply by another 2x squared y cubed z inches. All right, so when I do that, I'm going to go 3 times 2 times 2, which is 12, right? 3 times 2 times 2. Now I have x times x squared times x squared. I believe that's going to be x to the fifth, right? Because that's to the first power. Now I have a y to the fifth, y to the third, that's a y to the eighth, y to the 11th. Then I have a z squared, a z, and a z. So I believe that'll be z to the fourth. And then the most, well, not the most important part, but the part everybody loves to forget, inches times inches times inches is inches cubed or cubic inches. And there you go. All right, 3 more problems. You can pause, and then when you're ready, here come my solutions. So the bases are the same, so I'm going to add my exponents. Well, I've got a negative 2x and a positive 3x, so that'll be an x. A 4 and a minus 9, that'll be a minus 5. There you go. All right, here, I'm going to multiply 3 times 5. They're not a part of the x term, right? So I'll multiply 3 times 5 and get 15. Bases are the same, so I'm going to add the exponents. 2y and y is 3y. Negative 1, negative 6, negative 7. And there you go. Oop, I lost my x. Sorry. So it's 15 times x to the power of 3y minus 7. All right, this division one, oop, there's 2 more. I lied. I'm sorry. Actually, I'm sitting, but that's beside the point. I'm going to write as fractions. 6x to the 4y minus 2. I'm going to put that over 3x to the 5 minus 4y. All right, so, okay, well, I'm going to get a 2. And now I'm going to subtract these exponents. When you subtract these exponents, use quantities. Use quantities. Take the 4y minus 2 and subtract the 5 minus 4y. Why am I using quantities? Because when I subtract, why am I subtracting? Because I'm dividing like bases. I guess the fraction part was unnecessary, but that's okay. I have to distribute this negative. When I do that, I'm going to end up with an expression that looks like that. So now I'll combine like terms. I'm going to have 8y and a negative 2 and a negative 5 is a negative 7. And there you go. Ooh, what an ugly color of green. Okay, so come on down here. And I think I will write this one as a fraction. So the first thing I'm going to do is simplify the 5/10 to get 1/2. Okay, now I'm going to do the division. That the p term is going to go in the numerator, but I do have to do the 4q minus 1 minus 2 minus 3q. And remember, I have to distribute that negative. So it's going to look like that. So my exponent becomes 4q and 3q, 7q, and a negative 1 and a negative 2 is a negative 3. And there you go. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.